up over time, and you know, very high, maybe up at sort of 160 maybe. Other ones won't have such good fortune. You know, the randomness of numbers and so on won't be favour them, and you'll have some that sort of tend to drift down, and maybe they'll come down to 60. I'm sure where the bottom is. And there'll be other paths, you know, in the middle. But overall, they should tend to sort of track around this drift factor. It should be an equal distribution. If you do it sort of distribution at the end, it should become something kind of normal that way there. If you flip a distribution up that way, you should get a lot of observations around the mean here, and not many up on the extremes. So if our random numbers are distributed perfectly normally, you should get this beautiful, you know, Gaussian curve here, right? So that's what we're going to do in this assignment, is we're going to simulate where what paths an index could take over a period of 1 year. And understanding how these paths can evolve will help us understand the riskiness in a security, and it will actually help us solve for pricing of the option that we have on this security. So this is our index. We've got an option as well, and we have a futures contract over this index. So this course is all about derivatives. Here's our index. We're going to have an option on that index and a futures contract on that index. And then we're going to sort of look at paths that this index can take based on our knowledge of, or our estimates of its risk and its return. So you see there's two parts in return. There's the drift term, and then there's the stochastic term. Stochastic element in returns. And we're going to sort of model both of these factors and see how it goes. It's called a Monte Carlo simulation. And the other name for it is a lattice-based simulation. And you can go and look in chapter, chapter 9 of Whaley to see one of these exercises carried out. So we're sort of jumping a bit ahead actually, but it's okay, we can do it. We're jumping ahead, and we're going to do something that they actually do in chapter 9. So the first thing is we open this spreadsheet up and get these numbers in. So I've got that over here. So playing around with that now. So I'll save this as. So the first thing is get these numbers in here into these cells A and columns A and B. That information provided on the. Now this data is also on the website, isn't it? No. We can make this from scratch actually. So we just have to get these numbers in and these names here. Okay, so there's your first step. And then following through that assignment, the next thing we do is. So generate a bank of two, so where do we put that in cell? Some random numbers and put them in D10. Okay, so D10, come on to cell D10 there, and now we want to go data analysis. Where's that? Data. And that's, data analysis is not here, so that's our first thing. So you probably find you've got to go and get data analysis in, which I think you go File, Options. And what do we do? Add-ins. So File, Options, so just go through this. File, and then go File, see the options down here, Options. And then go Add-ins. And then there it is, Analysis Toolpack. So it's already highlighted, or is it? Highlight it. Analysis Toolpack. And then it's probably okay, so go. And, oh yeah, here we go. So now hit go, then click Analysis Toolpack. And then okay. Now you see over here, you'll see data analysis now on your Excel. They sort of hide it because it does probably take up some memory. So now what we'll do is go into data analysis. And it comes up as random number generation. We'll go OK. Now what do we do here? I think we go random number of variables 250. So we want 250 in there. Number of random numbers 100. Choose the normal distribution. Mean of 0, standard deviation 1, that's good. Random seed. The beauty about being able to put a random seed in is that you can always go back, to the exact set of random numbers and put a random seed in. Random seed's got to be 5 numbers. I'd recommend maybe, actually I saw someone went 1, 2, 3, 4, 6, and it seemed to give quite a nice set of random numbers. But we'll go 1, 2, 3, 4, 5, so that random seed, which is a bank of random numbers, huge bank of them. And it's actually, unfortunately, this bank of numbers is not actually that random, which is one of the problems you have with simulations, is that sometimes the random numbers aren't particularly random. And we'll put them into the cell here, output range D11, D10. D10. We'll drop them in there. So you go, okay. So there it is there, you've got all this big bank of numbers. And just looking here, I went and put a whole lot of, I went 1, 2, just so you know what you're doing, 3, copy that across. And go across 250. So 250 days, assuming that there's 250 trading days in a year. We're going to give a name for this thing here, so just go random seed. So then we know when we run around our Excel spreadsheet that we're in that block of information. And did I have a number here too? Yeah, I did. So let's put a number on it too. 1, 2. Now let's grab that and copy that down. Too big. Okay. Okay, so we've got this big block of random numbers. Going down 100 now, 250. And this is going to be 100 series going off 250 days in our simulation. If you have any questions at any time, just ask. Everyone got that? Who's doing it? how many are actually doing this, putting it in? It's quite good if you, someone actually does put this stuff in, so then keep up. Keep them engaged. So now what we need to do is go and get this formula here. Now, I've been having a bit of trouble with these formulas in Whaley, but I'm sure so different people wrote different chapters. I'm going to go with this one here, so which is out of chapter 7. So we'll drop down the bottom of this section of information. We'll just put this formula in here. So what we've got to do is work out what's the expected spot price, for the stock every day. And we'll be using this model here, which is a log normal exponential model for working out the how the stock price evolves. So in B, 3. Put in our prices, B103. Take those down about 100. And these are going to be our prices. And what else would we say? Yeah, okay, and then I'll put it on the top here. Run those out. Run that out 250 days of prices, so we can see where we are. Okay, the first day's price is going to be equal to cell B to B1, is it? B1. But actually it's going to be dollar B1, isn't it? So F4 it, F4 B1. So if you go F4, it fixes it at B1. So you should be able to copy that one down. And then price on day 1 is going to evolve according to this model here, and it's going to say here that it's going to be based on the stock price, the day before. But then there's going to be the drift factor and the stochastic factor will come into play. Now this drift factor, so we're going to go here equals that times exponent. How do we do that? Exponent. Exponential. And then this alpha term, which is that one there, 10% drift per year. B4 it. F4 it, right? F4 it, and then times 1 day. So T is 1 day there, so 1 day. Here's our day there, 0.004. So if you go 1 divided by 250, you get 0.004, so that's 1 day's worth of time. So that's close brackets there. So there's the drift term at work, 10%, we're going to make 10% per annum, and that means we make 4 cents on that first day. But there's also we don't actually want to close that bracket off yet, plus the stochastic term, which is our volatility first, so we're going to get that per annum volatility, which I've said is 20%, which is around about what most indexes, sort of what their volatility factor is per year, standard deviation. So F for that. And we actually need to F4 at P7. So volatility times the square root of dt. dt is that. That's a small number. And then times this random number, z. So z is our random number that we've just got in this block that we made. In your assignment, you've got to go and get your own random number. That's sort of one innovation you'll do. Go and get your own random number series. So I use the 1, 2, 3, 4, 5 series. You can use maybe a birthday or a lucky number. That's about right. Do I get it? 99.12. Close that bracket off. Oh, oh, it's doing a different thing. Yeah. Doing it slightly differently. Use a different formula. B7, B5 square root. Yep. Okay, that should be fine. Very similar anyway. I used the formula in on this first one. I used the formula of chapter 9, but it's only a very small difference. A little bit there. Slight variation. Okay, so there's our first price evolution. And then we should be able to copy that one across and down. Be able to copy that down, I think. Yep. Just copy that down. Looks good. So go and get that whole series there and copy that across. Ooh, how far across did we go? Can't remember. Just take it fair way. Oh yeah, still going. 211. A little bit more. Okay, 250. Here's our evolution of prices. Let's have a quick look at what they look like. So we go insert, line, choose the line graph, there they are. Oh. And so in fact we see here, it's weird how these things, little adjustments change things. We can see that some of the series get up to over 180 and some do get down towards 60. So in fact you see a bit of skewness there, don't you? So 180 is the top, which is 70 up, and the bottom is just above 60, so it's 50 down. Yeah, which is what you want actually. You want a model, you know, that's what that exponential model does. It gives skewness. Because stock returns are characterised with skewness, you know, positive skewness, which I've taken away. And so therefore, that's why Whaley uses that exponential model to get the skewness, you know, actually built into your simulation. So that's good, I think. So there's a nice little graph, and that's your first question, you know, graph the series. You don't need these, all the series information, but yeah, it's something along those lines, just to show that you've sort of got them working. And so these are all possible paths based on a drift term in the index plus this random factor that comes in every day for 250 days. Sometimes it's positive, other times it's negative, and sometimes it's net positive and other times it's net negative. So it's interesting, isn't it, that, this is how random numbers work. So look here, so these numbers are standard normal random numbers, so they should basically have a mean of 0. In fact, we could kind of do a check on it, mean of 0 and standard deviation of 1. So it means that 2 standard deviation event will give you a number either -2 or +2, So you should get a whole block of numbers maybe that range between maybe -3 to +3. Very few in the 2 to 3 zone, mostly all around, between 0 and 1. -1 and +1. And if you're a real nerd, numbers nerd, then maybe you would go and do an analysis of your random block, to see what are its characteristics, and perhaps I won't waste your time by, finding out what the mean and standard deviation of each of these lines are, but I think the 1, 2, 3, 4, 5 series is a little bit unusual. So that's all good. So we've done that. So generate these blocks of numbers. And then we move down here and we put in this formula and enter that formula in, so part 3 there. We'll just graph the different paths. So that's all good. Create a table of statistics as per table 9.3 of Whaley for the index and option using your own random seed. So here's this table here. This is what we want here. So let's go and grab this information and drop it into Excel. So what you do is you come along to the end of our series. Oh, there's some things you can do now to make it a little bit simpler. Is you can kind of hide a lot of columns so you can see more of the data. So let's just go and hide everything bar the first few. So just go right click and hide. And we'll also go and hide one of these series here. Okay, so now we can kind of see how to get rid of all this lot too. Let's hide all that. Okay, so here's all our data here, and we now drop those headings in. Okay, so now we want the simulation run. It's going to be these ones here. Copy those down. Terminal asset price, so just going to point at the last one. There's a fair bit of redundancy in this assignment, but it's okay. Some of these simulations just have, day 250 price and just use that model. They don't do it day by day. But by doing it day by day, you do get a feel for the risk within, within time periods. So here's our last simulation asset prices. Format that a bit so it's like that. Could even put a dollar on it if you wanted to. And then the terminal call price. Now the call has got a strike of 100, so you go. Just this is when the option expires. So now it's you're exercising it. So you go that price minus and point up there at the strike price. Put a F4 on it, and you get the. In fact, you need a max operator on this, don't we? So equals maximum of that or 0. Actually, this is where it'd be better we didn't have dollars. So the number there should be 0 anyway. That's okay too. Copy that down. It works. Oh, wait on. Maximum of negative on that one there. Did that work? Minus that. 0. Yeah, good. So we had three that are showing that are in the money. Of course, there's a lot that will be in the money. Terminal pool price, and then how do they compare? Quite a bit of difference just from that small adjustment in the method. And then we just go and get the averages and standard deviations. So we're going to get this stuff. Oh, didn't like that, correct? Okay, so summary statistics. For these series that average. Standard deviation. Standard error. Anyone know what the standard error is? It's the standard deviation divided by
The square root of n.
the square root of n. Thank you. And our n is, should we point at it? No, I don't think we don't have that number. Well, we do have it here. Suppose we point it there. 2.4. And the minimum, min. And the maximum. Come back, okay. Median, it's median, 50th percentile, 108. Okay, so there's some summary statistics, and we want to go and get these ones as well. The confidence intervals, which we'll use that standard error for. So the confidence interval is equal to the mean. Or maybe I should just have a look at the moment. Okay, so standard error. That's the mean minus 1.96. Yeah. What's the 1.96? Anyone know what that 1.96 is? That's the 5% level of confidence. And here's the big question. What's the option, what's the value of that option? And we just go, it's very simple. This is a Black-Scholes model. Yeah, so you just go and get that average price of the option. And that's in the future, you know, in 1 year's time. And so all we do is discount that by how much? How do we do this discount? I suppose we should go E, should we? Yes. So times exponential of. Usually I just go and divide by 1 plus the interest rate, but here we're in this exponential world, so we need that there, don't we? And this will be negative. To get a present value. So it's come down a bit, yeah. Ooh. Okay. What's that? Oh, yeah, times the T. Yeah, no, but T is 1, so it's 1 year away. Yeah. Yeah. So that should be all right. So there's the simulation estimate for the value of this option.